So in the last classes, we kind of discussed some basics of the relational data model. We discussed what are the normal terms regarding the relational data model. So we have relation, basically representing a table, attributes representing a table column, and the tuple representing a record or row in a table. And also we have kind of some constraints. We discussed the constraints that specified or supported by the relational data model, such as key constraint. I think last class we also discussed the domain constraint, null constraint, entity interpreter constraint. And also in the last class, we also kind of discussed what is a key in a relational data model. And also related terms we also discussed, like the candidate keys, primary key, and secondary keys. We also discussed the super key. So I want to review that the key basically, according to the relational data model, each table must have a key, okay? And a key can be a single attribute or can be a set of attributes that whose combined values is unique for every record in the table. I think the main purpose of having a key for each table it actually is that we are able to uniquely identify each tuple, so we will not allow the duplicate tuples or records in the table. And the key must satisfy two constraints. I think the key must satisfy two constraints: minimality constraint and uniqueness constraint. So that's very important. So this you need to remember that. So uniqueness means that no two records in the table have the same key value. Minimality means that if your key has more than one attribute, usually we call this case as the composite key. Then you have to make sure that every attribute in that key is needed in order to satisfy the uniqueness constraint. So minimality just means that if you have multiple attributes in the key, then you cannot have a redundant attribute, okay? Then we also discussed the primary key concept. So I just want to give you a quick review. So if you have more than one key, then you have to pick one of them as the primary key. Then the remaining will be called secondary keys. So that's why picking the primary key among number of candidates is pretty subjective. So it's really depending on the user or database designer. But anyway, so you only need one primary key. So even you have multiple keys, they all called candidate keys. So key means that they're candidates for the primary key. Then once you determine the primary key, then the remaining candidate keys will be called the secondary keys, okay? And also, we discussed the concept of the super key. So super key basically means a set of attributes that must contain a key at least. So super key can contain a key, and besides, it can contain some actual attributes besides the key, okay? So that's why super key still satisfy the uniqueness constraint, because it does contain the key. Because of that key in the super key, then it will guarantee that every record in a table will have a unique super key, okay? And then, I'm sorry, for some reason, I'm not sure if can you hear me now? I guess there's some kind of connection loss. I don't know. So it's, to me, I saw that your screen is kind of froze. So there's no, when I move up the slides, mean, it just freeze. It does not show the new slide. So the super key basically only need to satisfy uniqueness constraint, but you still need to understand the relationship between the super key and a key. A key definitely satisfies the super key's definition. So that's why a key is also considered as a super key, okay? But the super key might be a key or might be not. So if a super key contains some actual attributes besides the key, a key, then it's not a key. But if a super key only contains a key but nothing else, then a super key is also a key. Okay, so I think we kind of I think this somehow, I don't know if my computer froze or the network has some problem. So I think in the last class we kind of discussed several. Probably I do not use this kind of a presentation mode. So I think you're still able to use it very well. So we just discussed several model constraints based on the relational data model. So we discussed key constraint. So key constraint requires that every table must have a key, okay? So that it guarantees that every single record in the table is unique. And then the entity integrity constraint requires that no null values can be in the key field. So the primary key cannot take the null values. So if a primary key contains only one attribute, that attribute cannot take null value. If the primary key contains multiple attributes, then none of those attributes can take null value. Then we also have constraints on null. So for some database or some table, we do have some actual constraints on certain columns require that those columns cannot take null value. I think those kind of constraints on null usually are the application-based, or by application means that we have certain requirements on the data so that data can is able to serve on some application needs. And then the next one I think we're going to discuss is called the referential integrity constraint. So sometimes we call it foreign key constraint. So the referential integrity constraint specify a relationship among tuples either in two relations, two separate relations, or even in the same relation. So we call this relation one as the referencing relation, the other one as referenced relation. So the referencing relation will have a foreign key, and the foreign key will reference to the primary key or a secondary key in the referenced relation. Okay, so this is basically the basic idea. So why do we care for this relationship? Because foreign key and the referenced key relationship really can help us to decide the domain of the foreign key. Okay, so a foreign key can only take one of its referenced key values or null. It cannot take any other values. So in other words, the foreign key's values are constrained by its referenced key value. Okay, so it can only take one of its referenced key value or the null value, but nothing else. Okay, and so this kind of called referential integrity constraint. So in this case, referential integrity constraint will be specified by two pieces of information. The foreign key is one piece, and its referenced key, the second piece. So whenever we specify the foreign key, we have to specify the both information. Okay. So if we only list the foreign key without specifying what are the referenced key, then our foreign key definition or specification is not right. Okay, so that's you have to be very careful. So this slide shows how we can draw the foreign keys in a relation database schema. Okay, so we use this directed arc. So we have the kind of arrows, and also we have this arc. We have starting point, the ending point with the arrows. Okay, so the arrows always point to the referenced key. Okay, so key can be the primary key or can be secondary key, but they have to be key. So by key means that that attribute or set of attributes can uniquely identify each record in that relation. Okay, then this directed arc always start from the foreign key. Okay, so let's take the example in the dependent. So ESSN is a foreign key reference to the SSN of the employee. And here SSN is the primary key of the employee. And so when we specify the foreign key and the reference key, we have to make sure that the foreign key and the reference key, each corresponding attribute should have the same semantic, means same real world meaning. So we always have to be apple to apple, okay? Then the domain of the foreign key and the domain of the reference key should be the same. So that's very important. Domain, data format, and the semantics, the meaning. Okay. So if we given this database schema, if we have seen this foreign key definition, we definitely know that the ESSN of the dependent means an employee's SSN. Because this SSN is reference to the SSN, that means employee SSN. Okay. And let's see another example. On the employee table, we have DNO. Okay, so this in this notation, it means that DNO is a foreign key reference to the D number of the department. So D number is a referenced key, and the DNO is a foreign key. So by this notation, we understand that DNO stands for department number, and the DNO in the employee table, it can only take the values, all the possible, one of the possible values in the department, the D number of the department. Okay, so for example, if a department has 10 different D numbers, then this DNO can take only one of those 10 numbers. And sometimes, if not, the only possibility is that DNO is null. So it means that there's no value in that field. Okay, so that's why the foreign key constraint really can regulate what are the possible values a foreign key can take. So foreign key can only take one of the possible values, possible referenced key value, and it referenced to. Okay. So in this notation, we can tell that the D number of the department is referenced by 3 different foreign keys. So one is DNO, the other one is D number in the department location. Okay, so this is also foreign key reference to the department D number. The last one is the D num of the project. Is also the foreign key reference to the D number. Okay, so now you may ask, given department and the DPT location, okay, D number happens to be the attributes that appear both relation or both table. So using this notation, we can tell that D number is a foreign key reference to the D number of the department. Okay, but how about if we write in the other way around? I don't know if I'm able to do that. Yeah. I think it's better for me to insert. I need to make the arrow type. It's not that big. So if I try to use this notation, so it's kind of D number from the department. In this case, if I use this notation, that means D number of the department refers the D number of the DPT location. So this notation is not right. The reason I think we can use very simple kind of a rule. So foreign key always reference to a key of a relation, okay? So then if we use this notation, the arrow points to the D number of the DEPT location. That means that D number of the DEPT location is a key. Unfortunately, this conclusion is not right, because if you look at the DEPT locations, it has a composite key. So both D number and the D location are underlined. That indicates the two together work together is a primary key. But D number itself or D location itself cannot be a primary key of the DEPT location. So that's why I want you to understand that when sometimes if you got confused, do not know which is the foreign key, which is the reference key, then be aware that reference key is always a key. Okay, candidate keys can be the primary key or can be the secondary key, but must be a key. Okay, if you evaluate your foreign key specification, if you find out the referenced attribute or set of attributes cannot make a key of that corresponding relation, then you know that your foreign key specification is incorrect. So you have to examine every foreign key. So this is not right. I just want to let you know. Okay, so you have to make sure that the arrow always points to the key. Okay, so if the attribute or set of attributes the arrow points to is not a key, that means that the whatever you specify is not a foreign key. Okay. Another thing about foreign key and the reference key, so we call it union compatible. That means that foreign key must have the same number of the attributes as the reference key. So if the reference key has one attribute, then the foreign key can only have one attribute. If the referenced key, for example, has 3 attributes, then the foreign key should have 3 attributes, no more and no less. So that's called a union compatible, means that they have the same number of attributes, and also the corresponding attribute should have the same semantic, so same domain, same meaning, same data type, and the same storage format. So that's the requirement for the foreign key. Okay, questions? My computer is not worried. Don't worry, it's kind of sleepy, I think. Okay, then regarding to the other type of constraint. So far we kind of specify the explicit constraint or the model-based constraint. So there are key constraint, entity integrity constraint, foreign key constraint, domain constraint, null constraint. So those are all the constraints can be specified in the relational data model schema. Then the other type of constraint, and here we're talking about is what application-based constraint. Sometimes we call it business rules. So those constraints are actually based on the application's semantics and cannot be expressed in the model. Okay, and here give you one example, like the maximum number of hours for employee for all projects he or she works on is 56 hours per week. So this may be the hours defined by the company policy. So no one can work more than 56 hours a week. So this constraint cannot be specified as domain constraint, cannot be specified as specified as the key constraint and so on. So this is called application-based constraint because maybe same database and even the same company may be given different branches. They may have different constraints on how many hours an employee can work on the project. Okay. And then in the database, especially for the relational database, we can have constraint specification language that can handle the this type of application-based constraint. And also in the SQL programming, they also have assertion. So that's the mechanisms can allow us to specify some application-based constraint to enforce it. And also the triggers, database mechanism triggers. So triggers not only for the constraint enforcement, but also can be used for a wide of different usage for applications. So triggers can be also used for the database security, for the access control, and so on. So we can also use triggers to constantly watch out some kind of key field of the database to make sure that that field always has the accurate and valid values. So I think when it comes to the PL SQL programming, then we can kind of study how the triggers can be used to enforce application-based constraint and also can be used to enforce the database access. Then the populated database state. So that basically means that at any single point of time, we can take a snapshot of the database. So it shows all the data stored in the database. So the reason we define a database state because database is very dynamic. So at this moment, we have one snapshot, we have one database state. Maybe the next moment or next second, data changed in the database. So that's one database state will be changed. So every database state just record the data in a single moment of the database. And since database is very dynamic, so the state of the database will constantly change. Okay, but no matter how data change or database state change over time, we want to make sure that data is always correct and valid and consistent. So that's very important. So the quality of data should be very important because we have to use the data, for example, to support the student registration, was to support the kind of online retailer store, or to support the airline, flight reservation and booking. So we have to make sure that data is accurate so that it can be used to support an organization's operation, okay? But unfortunately, as data change, usually data change involves three different database operations. We can insert a new tuple, cause the database change. We can delete some existing tuples, or we can modify some existing tuples. So these three database operations will cause database state change. Then we always have to make sure that regardless of data change, we want to ensure the data will always be valid and accurate. So then the database constraint can be used to validate, okay? So validate if the data is okay. So theoretically, we want to make sure that all the database constraints will be always satisfied regardless how you change data, okay? But unfortunately, because of those database constraints, then the insertion, deletion, and modification can potentially violate a constraint. So we want to make sure that the database change will not violate those key constraints: entity integrity constraint, referential integrity constraint, domain constraint, and null constraint, okay? But sometimes the violation of those constraints caused by an operation cannot be avoided. Then we have to have some special strategy or special kind of a program to handle those constraint violations. So let's see the actions to take for the constraint violation. The first one, that we can cancel the operation that violates some constraint. Either violates, for example, we try to insert a new tuple, but that tuple has the same primary key value as some existing tuple in the table. So if this is true, then this violates the key constraint or primary key constraint. So for those kind of operations, we can either cancel those operations, means that we do not allow those operations be performed on the database. Or we can perform the operation, but we have to inform the database user to let them know that some constraint violation, so that they can take care of those violations. I think that's not considered very kind of a very good approach, but sometimes you have to allow this approach. For example, there are some kind of real-time database. Your goal is that you have to constantly model, constantly record the data the new data coming. So if the new data violates some constraints, you still want to save those new data, but you meanwhile also need to notify the database user to let them know that what's wrong with that data. So then they can pretty much can maybe correct or and decide how to handle those violations. The third one is that trigger additional updates so that violation is corrected. So this is actually often happens that they can call it the foreign key constraint violation. For example, I think in this case we know that in the example we have this D number of the department is referenced by 3 foreign keys spread out in 3 different relations. DNAM in the project, D number in the DEPT location, and the DNO in the employee table. Okay, so assume that maybe the company currently is kind of have some reorganization efforts. So they may want to, for example, remove or cut one department. Okay. So if a department is gone, then that operation or that reward actions should be reflected in the database. So that means that we probably have to remove one department record in the department. But then that removed department record, the D number, might be referenced by the DNO in the employee. So that means that there may be some employees originally working for that department so that they have DNO reference to that deleted department number. And also in the DEPT location, we do have some records record the location of that deleted department. And in the project, we also have some records, project records whose controlling department is actually that deleted department number. So then you compare that if we delete a department record, then some records in the DP location, some in the project, some in the employee, they no longer have a valid D number. Okay, so maybe let's see the example. Let me see. We have this printout, so we can. Okay, like this one. So here, this kind of just a table shows 3 tables: employee, department, and the DP location. And I think we know that there's several. There are at least 2 foreign keys. So the D number referenced to the D number of the department. Okay, then this D number. In this case, I have 2. Here is maybe, and this D number referenced to. Oh, God. So this D number reference to this D number, okay? Okay, so in this case, for example, if we want to, the company want to cut the research department, so that means that the research department record will be deleted from the department table. But then if we assume that we delete that record from the department table with D number as 5, then suddenly all the records in the employee table with D number as 5 no longer valid because company no longer have department 5. Similarly, for these DEPT locations, all the location records with D number as 5, they no longer are valid because they don't have, the company no longer have department number 5, okay? So for this kind of situation, and one possibility to handle is to do the we call cascade deletion. Means that if we delete a record from a table. If that record, has a primary key value referenced by some foreign keys in the other table, then we are going to delete those records whose foreign key reference to the deleted record. So in other words, if we delete department 5, then all the employee records with DNO as 5 will be also deleted. All the records with DEPT locations with D numbers 5 will be also deleted. I think there's one more, that project table also has DNO reference to the department number. So all the projects that are controlled by the department number 5 will be deleted too. So this is just one strategy. It's not for all. So really depending on the situation. Sometimes maybe the department is kind of cut, but they want to merge like all the employees to the other department. So in this case, this kind of cascading delete will no longer be appropriate. So then we probably have different strategy, like once on delete, we're going to kind of revise the referenced key, the foreign key to a default value or to a new value. For example, if the company wants to merge or reassign the employees who work for the department 5 to the department 4, then instead of deleting those employees' records, we just simply revise their D number from 5 to 4. So that's really depending on the situation and the company's needs. But anyway, so those kind of, I just want to demonstrate that when you delete a record, it can possible cause the referential integrity constraint violation. So we have to have the strategy to handle those violations. Because if you let the violation happen without taking care of it, then very soon the data will be very dirty. There are all kinds of invalid and dirty, inconsistent data records in your table. Then your table will no longer be usable. Okay, so that's the reason you have to take care of the constraint violation as quick as possible, so to maintain the quality of your data. Okay, questions? Okay, so let's move on to. So move on to the next one. Yeah. So the last one, so we were talking about trigger additional updates. So cascading deletion or on delete, we set to some null option or set default. So the last one is execute a user-specified error correction routine. So that basically means that we can use triggers to watch out the constraint violation and then perform the correction operations to make sure that at any moment there's no constraint violation on the data. Okay, so this shows that possible violation for insert operation. So when we insert a new record, we may at risk of violating all constraints: domain constraint, key constraint, entity integrity constraint, referential integrity constraint, or even the null constraint. Okay, because when we insert a new record, if for some reason a field does not, the field value does not fall into the all possible values for that field, then domain constraint is violated. If we try to insert a new tuple whose primary key already exists in the current table, then that will violate the key constraint. Because if you allow the insertion, then you end up with two records with the same key value. That is not allowed in the relational database. So that's why it will violate key constraint. And for example, if you in your new inserted record, if it has a foreign key value, okay, suppose reference to some reference to some key field or key value, and if the foreign key value is not one of the reference key value, and also is not the null value, then it will violate the foreign key constraint. And for the entity integrity constraint, it means that you insert a record if the primary key field contains the null value, then you're going to violate the entity integrity constraint, okay? And also for the null constraint, the same thing. So null constraint means that you already specify a certain field can never take a null value, but in your newly inserted record, for those fields, you does have some null value, then it also violates the null constraint. So pretty much inserting a new record, you may possibly violate, many constraints. So you should be very careful to make sure that new records does satisfy all constraints, okay? Deletion sometimes, so you already assume that before the database update operation, before the insertion deletion or update, the database is in a good state, means that all constraints are satisfied, okay? So this is the assumption for our discussion. Then if we delete a record, so before the deletion, all constraints are satisfied. Then for deleting a record, it will not affect the key constraint. Why? Because before the deletion, every record has unique key value. So if we delete a record, then remaining records still have this unique key value. So that's why deletion will not affect key constraint. Similarly, deletion will not affect entity integrity constraint. So entity integrity constraint requires that no null values in the primary key field. So if before the deletion it is satisfied, then the deletion will not affect because we simply delete a record, the remaining records still satisfy this entity integrity constraint. Okay. Domain constraint, the same thing. So before the deletion domain constraint are all satisfied, then the deletion will not affect that constraint. Okay. However, the only constraint that deletion might be affected will be the referential integrity constraint or foreign key constraint. I think we just discussed example already. So it means that if you delete a record, okay, if that record happen to contain the primary key that is referenced by some foreign keys, then that deletion might cause the foreign key violation. Okay, but there is a trick here. Okay, means that if you delete a record from a table whose keys are not referenced by a foreign key. So let's see the example here. Okay, so for example, the dependent. Okay, so the dependent primary key is ESSN, but ESSN is not referenced by any foreign key. ESSN is a foreign key reference to the SSN, but the ESSN itself is not pointed or referenced by any foreign key. So for this kind of table, it's okay for us to delete a record without violating the foreign key constraint, because this ESSN we delete when dependent, we will not violate any foreign key because ESSN is not referenced by anyone. Actually, in the dependent table, every ESSN, if it's valid, it should be one of the SSN in the imply table. When we delete a dependent record, for example, maybe an imply has dependent grown up, like, I don't know, according to the company's policy, maybe health insurance policy, maybe the case kind of, older than 25 years old. So maybe that dependent has to be removed from the employee's kind of dependence, right? The benefit. So that deletion will not affect anything. So this is a trick. So it means that if you try to delete a tuple from a table, and if that table's primary key is not referenced by any foreign key, then that deletion will not cause foreign key violation. Okay. So besides dependent, I think we also have like work sum. Okay. So for the work sum, we have a composite primary key, ESSN and PNO. And this composite primary key is not referenced by any foreign key. That's in other words, there's no records whose value, some of these attributes value will be dependent on the primary key's value here. Then it's okay for us to delete a worksum records without worry about foreign key violation. I think the last one should be the DEPT location. So DEPT location, also has composite primary key, and this primary key is not referenced by any foreign key. So it's okay for us to delete the DEPT locations without worrying about foreign key violation. Then the remaining relation, that employee, the employee SSN is referenced by 4 foreign keys. Okay, so that means that if we delete a record from the employee, we may risk foreign key violations. Okay, I think that's pretty sure. For example, if we delete an employee from the employee left from the company, then we're supposed to delete that employee's record from the employee table. And that employee may have some dependents, okay, who's stored dependents, whose information stored in the dependent table. So in the dependent table, we do have some records whose SSN reference to the deleted employee SSN. And also we may have works on table, and that employee may have some records in the works on table. So in this case, we do have some records in the works on table with SSN same as the deleted SSN from the employee table. So if that is the case, that means that delete employee's record will violate foreign key constraint. That means that we delete an employee record if we do not take care of the records in the dependent works on, and also maybe the department there's the MGR is also reference to it. Then we may end up with some records in this table that is invalid SSN, either MGR SSN or SSN in the works on table or SSN in the dependent. So that's caused the foreign key violation. Okay. Okay, so I almost forgot the. Where should I go to? So deletion only possible violate the foreign key. So it really depends on the which tables records we want to delete. So some table we may not be able to violate any foreign key constraint, but for some tables the foreign key constraint can be violated. Okay. The last one is update. So far we discussed insert and delete. The update operation, means update. We can update any field of some existing record. So for simplicity of thinking, we can consider an update operation is replaced by 2 separate operations. Means that we delete the old record, then we insert a new record. So we can do that. If we consider an update can be replaced by 2 operations, insertion and deletion and insertion, then we can tell that update might potentially violate all constraints. So if we update on the primary key field, we may possibly violate the key constraint. Means that if the new primary key is kind of a duplicate with some existing primary keys, then the key constraint will be violated. If we set during the update, we set the primary key field as null, then we violate the entity integrity constraint. Okay, and if we, for example, if the primary key, the record we try to update, the primary key is referenced by some foreign keys. So if we if the record we try to update contains some foreign key that reference to a key, either in the same table or in different tables, then if we put the wrong value in the foreign key field, then this foreign key no longer be held. Means that value does not match any value of the referenced key value. Then the foreign key constraint will be violated. And similarly, if we update some fields and the new value does not meet the domain constraint, then the domain constraint will be violated. So in short, update is like insert. It violates all four constraints we discussed, but maybe more like a null constraint. Okay, so you need to understand that part. And then let's probably have some exercise. So let me see if I'm able to. View. Let me see if I can find my table. If not, let me see if I'm able to open the one. I just want to have the screenshot of the database so that we can discuss. Maybe let me print out. Let me see what's the best. Yeah, probably can use this. And so far, the first one will be able to. Let me see if you're able to view it. Yeah, I think you're able to view it. Okay. So the first one, we insert very after those kind of record, fields, this record into the employee. Okay. We know the insertion can violate all four constraints. Okay. So we probably start with the key constraint. So key constraint. So we check the key field. I think for the employee, the key will be the SSN. So we have 1, 2, 3, 4. So this now will be the new SSN. I will be the SSN of this new record. So the null should not be in the key field. So this null really violates the entity integrity field. Okay. So the null, I don't have the. So this null is actually violating the entity integrity constraint, which requires that no null values in the primary key field. Unfortunately, this field stands for the primary key SSN. So this null is not good, okay? And we can also check the other field. I think for the first three fields, the domain constraint looks fine because they stand for first name, middle initial, and last name. Then after the primary key, that's a birth date, I think looks fine, okay? Then the address looks fine, at least domain, I think the charge string. And then sex, and then salary, and then super SSN, okay? Super SSN actually is actually in this employee table is a foreign key reference to the SSN. So in this case, we have both foreign key and the reference key belong to the same table. So I just kind of draw the foreign key. So from super SSN points, there's an arrow here, points to the SSN, okay? So now we know that this null, the second null in this new record, referring to the super SSN, okay? So it's a foreign key, okay, it's a foreign key. So recall that foreign key can take one of its referenced key value. In other words, super SSN can be either one of those SSN listed here or the null value. So since we have null here, that means that it's acceptable. So foreign key can either take one of its referenced key values or the null. So in this case, null should be fine. So the meaning, if we put the null, like I think the last record, like James broke. So if we have null in the super SSN, that simply indicates James does not have a supervisor, immediate supervisor. It might be the CEO, okay? So that's fine, okay? Then the last one, the 4, this D number is also a foreign key reference to the D number. So this also we need to be aware that. So this DNO is foreign key reference to the D number. So we have to make sure this is also so 4, I think, is one of the valid D numbers. So this 4 is okay. So overall, given this insertion, it violates only one constraint. That's the entity integrity constraint, okay? So that's kind of the one we need to make sure. So this kind of study just let you know that how we can, how we can evaluate if database updates is good or not. Good means that it keeps all constraints. Not good means that it violates some constraints. Okay, let's look at the next one. This time, still the same thing, we insert. Okay, Mary, done. Now we do have the, I think I want to mark, we do have this SSM that we need to make sure it's working. Okay. So this SSN, we have to check, because that's primary key field. We need to check if it satisfies the key constraint. And since it is not null, it satisfies the entity integrity constraint. So in other words, both key constraint and entity integrity constraint should be examined on the primary key field. And we also need to examine the domain constraint. And then this one is the super SSN, that's a foreign key. So we have to make sure this foreign key has valid value. And the last field indicates DNUM. So that's also foreign key field. Okay. So then this one, basically, we have to make sure it satisfies the entity integrity constraint because it is not null. But we need to make sure it also satisfies the key constraint. So how do we know? So we need to make sure that this new record whose SSN should be unique, should be not duplicate or identical to some existing SSN. Okay, so we just need to make sure that if we have this SSN in the current table, if yes, we do find that the Alicia, the Leia, and her SSN is the same as this one. So that means that this is not good. So it means that this really violates the key constraint. Okay, the primary key must be unique. And so we can also check other fields. So this is the super SSN, that's a foreign key. So we want to make sure that this super SSN is valid. Okay, so how do we know it's valid? So we need to make sure that this super SSN is one of the implied SSN. Okay, so let's say if we do have that super SSN. Yes, we do have this kind of Jennifer Wallace. So I have this super SSN. So that means this supervisor SSN is valid. The last one, 4, department number is also valid. I think we know that there are only 3 department number, 1, 4, and 5. Okay, so this means only the key constraint is validated. Okay, let's move on to the next one. This time we insert a record in the worksound table. So in the worksound table, basically the ESSN and the PNO together is the primary key. Okay, and this, when we examine the key constraint, we have to make sure the two together form the primary key. And also ESSN is a foreign key reference to the SSN of the employee. And the PNO is also a foreign key reference to the project number. Okay, so we have to know that P&O is also foreign key to the P number. So that's indicate that when we examine this insert, we first have to make sure that the key constraint is satisfied. If yes, then the second one we need to make sure that this SSN is valid and this P&O is valid. Okay, so we first just see if maybe it's better for us to examine if the SSN is valid or not. Okay, so we go to the employee table to see if there's any employee who have SSN as 111, 222, 33, 33. For, I think, yeah, 111, 22, 33, 33. Unfortunately, there's no employee who had this SSN. So this means that it violates the foreign key constraint, okay? And if you want, you can also examine if 15 is a valid project number. I think here it's not. Okay, so means that we violate foreign key constraint twice. So foreign key constraint. Okay, on both. The SSN and the P&O. Okay, so both are invalid values. Okay, so then we do the delete. So we delete work sum. Okay, so we try to delete a record. So recall that when we delete a record, and only foreign key constraint can be violated. Okay, so we don't need to worry about any other constraint. So then we see if the foreign key constraint will be violated. So since we delete the record from work sum, we just need to see if the work sum's primary key is referenced by any foreign key. Okay, so the answer is no. Okay, so the primary key will be yes and the P number. So the two together is not referenced by anyone. So I think we have that. Let me see. We do have this this kind of a database schema. Okay, sorry. Okay, in this database schema, for the work sum table, I mean, we only have seen that work sum has two foreign key reference to the primary key of different tables, but works on itself, the primary key is not referenced by any foreign key. So that means it's okay to delete. We don't need to worry about any violations. Okay. And also, I want you to make sure that when we do the deletion, we said, delete the work sum tuple with SSN equals to this one and P&O equals to this one. So this gave you the primary key value of the work sum. So we know exactly which record we're going to delete, okay? So it's going to be this one. We're going to delete this record because given the primary key value, there's only one record can contain that primary key value. So there's no confusion. Okay, so this deletion is okay. No constraint. Okay. Then the next one, this time we delete the project record. Okay, so if you look at the project record, okay, so it's P number, actually, the primary key is referenced by P&O of the work sum. So that's really indicates that if we're trying to delete a record in the project table, maybe there's some foreign key violation, because if there's some records in the work sum table with the same P&O, then if we delete record from project, then those P&O will become invalid. Okay, so let's say we delete the project tuple with P numbers 1. If you go to the workshop table, yes, we do see several records with P number as 1. So that's indicate deletion of the first record in the project table will cause foreign key violations, okay, or entity integrity constraint violation. This violation means that we delete a record from project, then we do have several records in the workshop table no longer have a valid P&O. Okay, so in this case, deletion of this project tuple will violate the foreign key constraint. Okay. So once again, deletion only possible violates foreign key constraint. Okay, it won't affect the other constraints. So let's look at the next one. So here we want to update the salary of the employee tuple with SSN equals to this one to 280. So the reason we want to give the SSN because in the employee table SSN is a primary key. Okay, so we know each employee has a unique SSN. So given this SSN, we're able to find an employee's record, one and only one. I think in this case that should be the initial the layer. Okay, then once we find that record, the only thing we want to change is the salary. Okay, so salary is not the primary key of the employee. Salary is also not a foreign key referenced to some key. So salary base is not that important. Then for those kind of fields, we only need to examine the domain constraint. So in this case, 28,000 is some. I think it's pretty low, but some is at least a valid salary. Maybe this person is part-time. In this case, we consider this deletion is update is okay. It does not violate primary key or key constraint, entity integrity constraint, because the update field is not a key field, and also it's not foreign key field. So that's why we only check the domain constraint. So it's okay. So this one is okay. Okay. So then we have the last one. So update the manager SSN of the department tuple with D number equals to 1 to this one. So this time again, so we want to update a department record. The reason we gave the manager's SSN, the D number, because D number is the primary key of the department. So with D number as 1, we can have only one record. Okay, so we're able to retrieve the corresponding record and only one record. That will be the headquarters department. So we want to change its SSN, manager's SSN, to this one. Okay, so we know that manager's SSN actually is a foreign key reference to the primary key of the employee. Okay. Okay. So then if we want to update this MGR system, we have to make sure that the new MGR system should be one of those valid SSN in the employee table. So let's see this MGR system. Okay, so MGR system will be 9988 7777. And yeah, we do have this one. Okay, so it means that new manager's SSN is a valid employee SSN. So in this case, this update is also okay. Okay, so I think one trick for the update, we need to first look at which field is updated. So if the field belongs to the primary key, then we need to examine the key constraint and entity integrity constraint. If the updated field is and also the update field is foreign key, we have to make sure the that foreign key field has valid value. If the updated field is not the primary key field, is not foreign key field, then we only need to check the domain constraint. Okay? So any questions? Okay, so just give me 1 second. So I need to report that you get my cell phone. Okay, so I think that's pretty much for today. So I think I just posed the first assignment to the Blackboard. I think you're able to work on the second questions. So the first question, I think next class we're supposed to be able to cover the functional dependency and also how to calculate the closure of a set attributes given a set functional dependencies. So I think you go ahead and work on the second part of the questions. So for the assignment, I would like you to submit, through online because you have the link for the submission. And also, you have to do it electronically. So you can either type your solution using any like a Word document or text editor, or you can handwrite your solution and then just scan it or take a picture of it and upload to the Blackboard. So if you handwrite, make sure that your picture is clear enough so that I'm able to read, okay? So that's kind of the requirement for assignment submission. But anyway, if you have any questions regarding to assignment, and just let me know and send me email, or if you need help, okay? Any questions?